Hello students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about a very interesting topic. That is, when we look at the map of the world, the rectangular map of the world especially, what we see is actually not a correct representation of how our world looks like or how different countries and land masses look like. So what exactly is wrong with our map? What is the challenges that the cartographers and geographers have to face since last 500-600 years so that they are able to represent the three-dimensional spherical earth in a two-dimensional map. So to give you the context of this particular topic, mostly if we talk about the maps that has been designed since last 600 years, all the maps are designed with best of intentions, mainly so that they are able to provide detailed and coherent projections of the earth. And as far as the maps, especially the flat maps are concerned, despite these noble intentions, are far from accurate. For example, the main issues that the map of the world today faces is that some areas on this map look far bigger, while some areas look much more smaller than they really are. At the same time, every world map, no matter which cartographer or which geographer do we follow, every world map is distorted in some respect to some extent. However, the most common maps that we use today in across the world is the Mercator map, which is published in 16th century, and the Peters map, which is published in very recent times. So let us first try to understand the Mercator map, which has been always the most popular, most widely used map since at least last 500 years. So Mercator map was actually given by a Flemish cartographer and geographer in year 1569 by the name of Gerardus Mercator. And the main purpose with which he has made this map was mainly to use it as a navigational tool. And that is why, while preparing this map, he has basically used rectangular lines and rectangular shapes so that they are able to represent correctly the latitude and longitude and their intersection in different parts of the world. And it is due to this reason, when he has drawn this map, he drew the latitudes and longitudes as parallel to each other throughout the map area. So obviously, his main objective was not to correctly depict that how exactly the countries look like, what exactly the shape configuration of the land masses, what actually is the size of different countries and the land masses. Main purpose behind his designing of the map was to aid the navigators at that time, who used to mainly go through the sea routes from one place to other place. And thus, if suppose a person want to travel from Mumbai to Dubai, then he can just chart a straight line on this map, and by following this map, he can then reach that particular point. So thus, as far as the straight line drawing on the maps are concerned, as a navigational tool, the map has actually fulfilled its purpose, fulfilled its promise. However, the problem that the Mercator's map faces is the sizes of different land masses are very different than what exactly they are. For example, if you take a look at this map, which is the Mercator projection map, we can see here this is our Greenland. And if you look at the size of Greenland, it looks almost bigger or at least comparable to Africa. And definitely Greenland looks much bigger than the overall country of Mexico. But that is far from true. Not only that, even if you look at the overall extent of Russia, it looks much more bigger than what it actually is. Similarly, the North America, including US and Canada, looks much bigger than the continent of Africa, but this is far from true. So what is the issues the Mercator map has been facing from past 500 years, and why it has been criticized every now and then by the geographers and cartographers? So first of all, it shows, as we have discussed, Greenland and Africa to be similar in size, but in reality, Africa is almost 14 times bigger than the Greenland. But if you look at this map, you can see that how disastrous is the depiction. Similarly, if you take some other example, Greenland appears to be also greater than the entire continent of South America. However, in actual area, Greenland is smaller than even the Arabian Peninsula. And similarly, if you look at the 50th state of USA, that is the Alaska, it is depicted as around 3 times bigger than that of Mexico. But in fact, Mexico is around 1.3 times bigger than the Alaska. So these are the issues that the Mercator faces. And if you look at this particular, actually, if you try to understand that, if you try to actually shrink the world and actually represent all the countries, how exactly they look like on the earth, it will look something like this. If you take a look at this video, you will be able to understand that where we are facing the problem. So this is the map as per the Mercator, but when you reduce all the countries to their actual size, they will reduce to something like this. We can see now Greenland is become very, very smaller. Greenland is much smaller as compared to other countries such as India, especially Africa, and also the size of Russia becomes much more lesser than what it is observed on the map. So let us try to understand in more detail that what are the other differences that we observe on the Mercator map. So if you look at the Africa and try to compare different land masses with Africa, we will understand that true size of Africa is much more gigantic. For example, the entire African continent is almost 30.4 million square kilometer. Russia is only 17.1 billion square kilometer. And if you arrange Russia longitudinally from top to bottom, it will cover the entire African continent like this. Similarly, US is much more smaller than Africa, China, Brazil, Europe, and even if you look at the India is almost 1/10 of the size of Africa. But if you actually look at the world map that is hanging around the walls of schools, colleges, institutions, we will see these differences is not observed to such extent. If you compare the map of Africa and compare the map of India, it seems that India is maybe 1/3 or 1/4 of Africa. However, it is 1/10 of the Africa. So these are the problems that the Mercator map faces. So the obvious question arises that why we are not able to depict correctly, or why Mercator when he is preparing his map was not able to correctly depict the sizes of each of the land masses. So first reason is because by drawing a rectangular map, we are trying to represent the three-dimensional world. We are trying to represent the three-dimensional obloid sphere or oblate sphere that is the shape of our Earth in a two-dimension. And there the problem arises, because if you look at the meridians, if you look at the actual globe, which is the actual representation of the Earth, all the meridians converges near the North Pole and the South Pole. Also, the lengths of the parallels of latitude decreases until the pole. And when you try to represent this particular information on a rectangle map, what happens? The poles has to be stretched from points into lines. For example, what I'm trying to say is that in the actual globe, the poles are 2 points, North Pole and South Pole. But when you try to represent the same poles on a rectangular map, you have to convert this stretch all across into a line. And that is why the length of the poles become almost similar to the length of equator, which is a very, very incorrect description. At the same time, all the parallels of the latitude is stretched same to the length of equator, but that is also incorrect. Because if you look at if you look at the globe, we know that equator is the longest line, longest circle, and as we are moving from equator to poles, what happens? The circumference of the circle and the radius of the circle keeps on decreasing. However, in this rectangular map, we do not take into account this particular fact. And parallels are equally spaced on the globe, but Mercator's projection exponentially increases the separation of parallels as one moves forward. This is done mainly to get the spatial property of great circle and straight lines, and therefore there is an increasing vertical stretching as one moves forward on the map. Let us try to understand the same thing in the context of how by changing the place or position of two different places, we can actually understand how sizes are presented or misrepresented in the map. For example, if you take a look at the Greenland and if you take a look at the Mexico, now if you replace Greenland with Mexico, we will see that the Mexico will become much more bigger in size and the Greenland becomes almost similar in size to the Mexico. So this is what we are talking about, that as the Mercator has to take into account the conversion of globe into the rectangular map, he has to increase the vertical stretching toward the poleward areas. So overall, if you look at the projection of Mercator, how he was able to project the map on a rectangular shape. So this is our globe, that is the actual presentation of our Earth. As you can see, this is our North Pole. This will be our South Pole. So as we can see from here, this is the equator. And as you're moving from equator toward the poles, what we are seeing has happened that the distance between 0 to 30 degrees is, suppose this is X, but distance between 30 to 60, that means the same difference of 30 degree latitude, when you are moving more toward poles, now this distance is becoming bigger than X. And if you compare the same distance of 30 degree between 60 degree to 90 degree, we can see the map has to be stretched out almost 3 to 4 times as compared to 0 to 30 degree. So obviously, if you are stretching out this particular area, if you're stretching out the particular area, suppose for example between 60 degree to 90 degree on the globe, obviously all the land masses, they will seem to be much more bigger because these land masses are also getting stretched out. And that means if you are actually reducing this to their normal distance, this will be distance like that, and the green line is where of this particular size of this smaller size. So it is due to this reason the Mercator map is not a true depiction of our world. So question comes that what is the solution? So first of all, after Mercator was criticized, there have been several other flat maps. For example, Peters map was drawn over the century, but the problem is that all these maps to some extent faces the same problem. The reason is very simple, because it is almost impossible to portray the three-dimensional earth on a two-dimensional map without compromising on either the size of the land masses or the shape of the land masses. For example, if suppose we are not stretching vertically the map as we are moving toward the poles, so obviously the distance will become same, but at the same time the shape, the actual shape of the contents will become much more distorted in nature. However, in recent time, the National Geographical Society of the world is preferring a map that has been designed in year 1921, that is called as Winkel triple projection map, because this is believed to the most accurate rectangular map that exists today. And the reason behind this is very simple, because if you look at this map here, we can see the world or the globe has not been exactly converted into a full rectangular shape, rather than the spherical shape of the earth has been taken into account. And that is why, as we can see, that as we move from equator to poles, we know that the distance gradually decreases. So that has been taken into account to a certain extent. And thus, what we can say that the Winkel triple projection is known to have one of the lowest mean scale and area distortion among all the other projections for small scale mapping that exist today. Now, apart from that, recently also some more efforts has been made, and in 2021, astrophysicists have produced what is believed to the most accurate flat map of the Earth ever. This is also called as pancake map, because in this mapping, what the astrophysicists have done, they have actually considered the Earth to be made up of two round pancakes, and they have superimposed both sides of the Earth on this particular map. So it can be viewed side by side, or even it can be viewed as back to back. So this is believed to be the most correct, or most, what we can say, the accurate description of the world's structure. So what we can say in conclusion, that the all maps lie to some extent when we refer to a maps need to simplify, falsify, or even conceal the realities of the 3D world into 2D map. However, the lies that maps tells us, it can range from some forgivable lies and necessary white lies to more serious lies which often go undetected and belie the agenda of the map makers. So that is all about this particular video. I hope you understood the problem that the cartographers have to face. If you like the video, please hit the like button, share it with fellow aspirants, as well as subscribe to our channel for more such content. Thank you very much.